Is the screen visible, students?
Yes, ma'am, visible.
Okay. A very good morning to one and all. So today we will be studying the next topics of this third module. Yesterday we had studied about the asynchronous dynamic RAMs. So we know the difference between the static RAM and the dynamic RAM. What about static RAMs? Static RAMs will lose the data once the power is cut off. But dynamic RAMs do not lose the data. But what another difference we are having here is, for us dynamic RAM we require to refresh the data every some amount of time, after every periodically we have to refresh the data so as to maintain the charge on the capacitor. So if we do not maintain the charge on the capacitor, the data will be lost. That is why we have to maintain the charge. To maintain the charge, what we have to do, just if you access that particular row, if you access or if you read that row, then the automatically the data will be refreshed. So on an average, after every 16 milliseconds, we have to refresh the data. And we have also seen about the block diagram yesterday, how we are going to read the data, wherein we were having 4K into 4K organization. So each row consists of the 4096 cells, and columns contained also 4096, but they were divided like 512 bytes of 8 groups. 8 groups were there. So first group, second group, third group, like this 8 groups were divided. 4096 was divided into 8 groups, each of 512 bytes of data. So first we latched the row address by generating the RAS signal, that is the row address strobe signal. So this is an active low signal. So whenever it is in the lower position, then it is considered as an active, this one. Then after strobing the row address to the latch here, then the column address was also strobed. After that, the row address and the column address were decoded, and using the sense and the write circuits, sense is used for reading and the write circuits are used for writing the data into the memory with the help of the CS, that is chip select signal. Which of the chips should be selected for writing among the 8 groups, means among the 8 columns, which columns should be selected. So that is what we have to do using this chip select signal. And read and write signal is going to give me whether I have to read or write. So if it is a 0, then it means we are going to if it is a 0, then we are going to what, we are going to read or write. If it is a 0, what we are going to do, we are going to read or write. Fast, tell me. Yeah, it is a read or write.
Right.
Yes, we are going to do the write. Then if it is 1, we are going to do the reading operation. After that, when we are going to do the reading operation, whatever data is to be read, that data will be transferred on this output data signals D0 to D7. If you want to write the data, first we are giving input to this D0 to D7. That data is then taken by the row address and column address, and then it is written into the address which is mentioned in this row and column address. This is what we have seen here in the asynchronous dynamic RAMs. So today we are going to study about the synchronous dynamic RAMs. Arrangement of all the block diagrams is the same here. For synchronous, arrangement of all is same. Only the thing we are going to change here is we are going to use the extra registers, input registers. We are going to use the extra input registers here, and also we are going to use the register for output also. So, and we are having something extra called as refresh counter. We are having, what is this refresh counter? In the asynchronous dynamic RAMs, we had seen that whenever we want to refresh the complete 8 groups, what we were doing, we were using the same row address, and first we were giving the first group's column address, then we are giving the second group's column address. Manually it was given, sequentially we were giving the address of the first group, second group, third group, like this sequentially we were trying. But here, instead of sequentially giving it manually, what we are having a refresh counter. So by itself automatically it will start providing the address from 0, 1, 2, 3, 4 up to all the groups. So this a refresh counter is used for giving the column address. Okay, for giving the column address sequentially, we are having this refresh counter. Then everything else is the same here. So what we are having, first we were having, see, you can also see here row address and column address is not given to this latches here. So it is given to another block called as a mode register and timing control block. This mode register and timing control block will generate this the row address strobe, column address strobe, chip select, read write, and clock signals. So this is a synchronous uh, synchronous this is synchronous DRAMs. Okay, dynamic RAMs. What is synchronous dynamic RAMs here is everything signal is generated with the help of the clock signal. We are generating with the help of the we are going to generate all these signals here. So procedure is the same. So what this mode register will do, we'll see a bit later. So for now, this mode register, when it generates the RAS and CAS signal, the row address and the column address will be latched into this particular blocks latches. Okay, first the row address will be given, row will decode, and that particular from the cell array, that only that row will be selected. After the row is selected, the column counter or the column address will be strobed under the control of CAS signal, which is generated by this register. When the CAS signal is generated, the column address will be kept in this column address counter. Then it will be given to the column decoder using the row address and the column address. That complete row and column will be selected using the read write signal. The data will be transferred either to the input register or to the output register. So what is this data output register? If you are doing the read operation, okay, if you are doing the read operation, you have to read the data and you have to get it back to the user. Is it not? You have to read the data and bring it back to the user, means you have to output the data to the user. Is it not? That time, if you are doing the read operation, data is stored in this data output register. Once the data is stored in this data output register, it will be transferred to the data output lines. Okay, it will be transferred to the data output lines. What about this input register? Suppose you want to do the write operation. So when you are going to do the write operation, first you have to give the data to it. Is it not? You have to give the data for writing in the memory. So that time you are storing first the data into the data input register. Once the data is stored in this data input register, using the row address and the column address which is generated by the processor, will be this data will be taken, and to that particular address data will be stored. So this is the main usefulness of this input and output register. So in the asynchronous, what we had, directly we had the data lines. Is it not? So we had directly the data lines, but here what we are having, we do not have the direct data lines. In between the memory and the output, we are having these two register, data input register and data output register. So this is how synchronous DRAMs will work. I am saying synchronous. Synchronous means there is only one clock signal. There is only one clock signal. So one clock signal, under the control of that clock signal only, all the data will be transferred here. But here previously we had seen in the asynchronous, what was happening? Each of the circuitry were generating their own clock signals. Is it not? So here what we are doing, a specialized memory controller circuits provide the necessary control. Each of the blocks were having their own memory control circuits. In the, I am speaking about asynchronous now. Each of them were sorry, each of them were having their own control circuits which were providing the timing diagram. But that is not the case in this synchronous DRAMs. In the synchronous DRAMs, there is only a single clock signal. You can see here, this is a single clock signal. Using this single clock signal, all the generated are synchronized with this clock signal. They are synchronized with this clock signal. That is why it is called as synchronous dynamic ramps. Okay, why it is called as synchronous dynamic ramps? Because there is a common clock which governs, or under the control of the common clock, all the other signals will be working. So this is how it happens. Let us study this. So in this timing diagram of the synchronous, we are having what? We are having a, see here, you have burst read length of 4, means we are reading 4 bytes of data, D0, D1, D2 and D3. How these 4 bytes of data will be read using all the signals we are going to see here. See, this one upper part of the clock signal and one lower part of the clock signal will form one cycle. So this is one cycle here, one upper part and one lower part. This much is one cycle. Okay, so this is one upper part and one lower part. So this is a one clock signal. We are doing a read operation here. So see, first what happens, under the control of row address strobe, means row address is strobed in the first cycle. Row address is strobed in the first cycle, and it takes a delay of 2 cycles. See, this is one cycle and this is another cycle. It takes a delay of 2 cycles for uploading that row address. Once the row address is uploaded, at the same time the column address will be strobed. See here, in this one row address, first cycle itself row address will be strobed. Then he takes a delay of 2 clock cycles for selecting that particular row. After selecting that particular row, here column address will be strobed. Okay, column address will be strobed. Once the column address is strobed, now what happens, read and write signals will be already generated here. Whatever we want to read or we want to write, that signal will be already generated in the first 3 cycles. So using this one, though it will take one more clock cycle delay for getting the uh, first data. So in the first clock cycle, what is happening, row address is given. After a delay of 2 clock cycles, the column address is also inserted. After inserting the column address, after 1 clock cycle delay, what is happening in this 1 clock cycle, using this row address and column address, the first data byte will be found. So it takes the 1 cycle delay, 1 clock cycle delay is happening. In this delay time, the first data byte is found. Once the first data byte is found, it is kept on the data line. So then immediately, without any delay, you can see when you are getting the first address, so by sequentially incrementing the address to the next one. So now we have seen, when we take a 32-byte computer, so if my address is beginning at 5000, so next address will be 5004, because 32 bits means word length is of 4 bytes. 4 bytes equal to one word. So first word is beginning at 5000, second word will be beginning at 5004. 4 bytes is equal to one word. So simply by incrementing the address, next data bytes will be next data byte will be sequentially kept on the data lines without any delay. Now you can see, a read write signal, RAS signal, CAS, address and data, all of them are working under the same common clock signal here. So they are called as synchronous dynamic RAMs. Okay, synchronous dynamic RAMs means all of them are working under the same control of the single clock signal. So after transferring all the data, the row address and column address will be taken off. And see, once you are using that row address and column address, it means that it is refreshed. Okay, that complete row is refreshed. How it is refreshed? By using this one. What is that? refresh counter. We are having a refresh circuitry which is containing a refresh counter. So here, even though we are taking only 4 bytes of data, we have seen there are 8 groups, is it not? So out of 8 groups, we are already taken 4 bytes of data. What about the remaining? The remaining also will be refreshed using this refresh counter, where the column address counter will sequentially go on providing the address of the next columns. So once you are reading a row, that complete row will be refreshed. So like this we are going to do here. And we are having different burst mode of operation. We are having here uh, so we are having here mode register. What is this mode register doing? Mode register will tell you the mode of operation. We will be transferring the bursts of data here. What do you mean by bursts? Burst means it is a block of data. It is a block of data. Here we are not transferring word by word, one word, second word, third word. We are not transferring word by word here. We will be always aiming to transfer a complete block of data. Why we are doing this, we have already seen in direct memory access. So if we transfer a data word by word, then after every transfer of a word, interrupt signal should be generated. But this will become hectic. To avoid this, we are going for transfer of a complete block. Direct memory access means a direct block of data is transferred from the memory to the processor, or processor to the memory, or including any device. So when the complete block is transferred, then one interrupt is generated. Because of that, we are going for the complete block transfer. When we are doing the complete block of transfer, each block will be having variable length, is it not? Each block will be having variable length. So we have to provide the information to the processor or to the memory, what is the length of that burst, or what is the length of that block of data. That is given, that information is given in this mode register. So mode register is going to indicate how much you are going to see. Mode register burst operations of different length can be specified. We are having a variable length of the blocks. So what is the length of that block which we are going to transfer, that we are going to specify in this mode registers. So this is how the working of the synchronous dynamic rams takes place. Have you understood this one? Have you understood? Please reply. Drop a message in the chat box. Yes, reply. Have you understood or not? Fast. You can drop a message in the chat box. See, don't you net because of network issues, you people will not be audible to me. That is why you have to drop a message all the time. Yes, have you understood? Anybody can tell me.
Yes, ma'am, understood.
Okay, very good. So next point which we have to consider is about the latency and the bandwidth. So we will be seeing what is this latency and bandwidth. Latency means it is a kind of delay. Okay, when you are transferring the data from when you are transferring the data to and from the memory, or to and from the processor. So you have to keep in mind what is the performance, or what is the speed with which the data we are going to transfer. So the performance is also another consideration to be taken when you are going to rate the performance of a computer. Is it not? How it is performing, how efficiently we are going to transfer the data. So while considering the performance, these are the two important factors which we have to take into consideration. Which are those? Latency and bandwidth. Latency is termed as the delay. Latency means it is delay. This delay is different when you are transferring one byte of data at a time. One byte in the sense one word of data at a time, and a complete block of data at a time. So what is the latency when you are transferring a word of data? So when you are transferring a word of data, see here, in case of reading or writing a single word of data, latency provides the indication of performance. What does it mean? It means that what is the sorry what is the delay in transferring successive words of data, amount of time it takes to transfer one word of data to and from the memory. Okay, one word of data. So how much time it is taking to transfer the one word of data? Now here we have seen, so after, even after the row address and column address is given to the system, the memory takes one cycle delay. After one cycle delay, the next denote first block is transferred here. Is it not? First block of data or first word of data is transferred. The difference between this time after providing the address is called the latency. This is the delay. The delay of one cycle here tells you the latency. This latency is different for when you are doing one word or single word transfer and when you are doing burst transfer. So when you are doing the single word transfer, the time taken to transfer the complete word of data is called as latency. When you are transferring a single word, the latency or the memory latency is termed as, or it is the time taken to transfer the one word of data. Then when you are doing the block transfer, the latency, it denotes the time it takes to transfer the first word of data. When you are doing the block transfer, see here we are doing the block transfers, is it not? We are transferring 4 bytes of data, one 4 bytes of data, or 4, this is one complete block. In this complete block we are having 4 bytes of data. Example, okay, we are having 4 bytes of data, or let us consider we are having 512 bytes of data. This block is containing 512 bytes of data. So to transfer, after the row address and column address is given, what is the delay it is taking for transferring only the first byte of data? Only the first byte. See, because the second block of or second byte of data, automatically without any delay it goes on transferring. So what is the time taken to transfer the first block of data, first byte of data? That is in the block transfer, that is the latency in the block transfer. When we are doing the block transfer, latency means it denotes, what it denotes? It denotes the time taken to transfer the first word of data. When we are doing the block transfer, the latency denotes the time taken to transfer the only the first block of data. But when we are doing the single word transfer, so what is latency? The time latency is the amount of time it takes to transfer that complete word, only that word. Here only the first word. When we are doing single transfer, only the time taken for single word to be transferred. When we are taking block transfer, the time it is taking to transfer only the first word, so that is called as the latency. So in general, this latency should be very minimum. Latency means it is delay, is it not? So the latency taken for transfer of data, either it is a single word data or a block transfer data, that time it should be minimum. Latency delay should be minimum. Then next, about this one, what is that? About the bandwidth. What is bandwidth? Bandwidth is the number of bits or bytes that can be transferred in one single second, in 1 second. That is called as the bandwidth. The number of bytes or bits that can be transferred in 1 second, that is called as the bandwidth. It is the bandwidth of the data. See, these two are, I told you that latency and bandwidth, these are the two important factors which have to be considered for finding the performance of the system. Actually, these are not actually sorry, these are not only the two factors. We have to also depend on the speed of the memories here. Performance of the system is not only dependent on the bandwidth, it is also dependent on the speed of the memory, how fast the memory is working, and it also depends on the type of bus we are using. So how bus is considered is, see, we are transferring the data with the help of the buses, is it not? So let me take a very real time example. So you are, all of you charge your mobiles, is it not? Suppose you are having a XYZ mobile. That XYZ mobile will charge fast with its own charger, is it not? XYZ mobile, XYZ charger, fast transfer will fast charging will take place. Suppose if my mobile is something XYZ and I am using a charger of PQR, so it will be charging, but it will take more amount of time to charge, is it not? Means depend the charging is also dependent on the cable which we are using, is it not? In the same way, even if the memory is faster, but the bus should be more strong enough, it should be speed enough to transfer the data. So solely the performance of a system does not depend only on the latency or only on the bandwidth. It also depends upon the speed of the memory and the type of the bus we are going to use for the memory transfer. So this is how we are going to rate the performance of a system using this latency, bandwidth, and speed of the memory and the speed of the buses. Next, we are going to study about the double data rate RAM, that is synchronous DRAM. So, double data rate means what? Till now, what we were doing, we were transferring the data only on the rising edge, one edge. Only on one edge we were transferring the data. On the rising edge we were transferring. So double data rate means what? We can transfer the data both the sides. So we can transfer the data on both the edges. See care, on both the edges we can transfer, falling edge also and rising edge also. So such devices are known as double data rate uh, synchronous dynamic RAMs. They are called as synchronous dynamic RAMs. Double data rate means what? They can transfer the data. Transfer the data in the sense they can read and write the data on both the edges, rising edge and falling edge as well. So they are called as double data rate devices. This much is enough for this one. So next we'll be studying about the structure of larger memory. See, I'm going a bit faster here because this is a very simple concept. Double data rate means what? Double, the name itself is indicating double, means rising edge also you are transferring the data, falling edge also you are going to transfer. What is rising and falling edge? This is a rising edge, this is a rising edge from down to up, this is a rising edge. Next, this is a falling edge, up to down, up to down, this is a falling edge. So transfer takes place at the rising edge also and at the falling edge also. So that is called as double data rate transfer of data devices. So next we are going to see about the structure of larger memories. See, whatever we have seen here, it was a very small uh, small, like for example we had only 4K into 4K, or we had 128 into 8, 16 into 8. Very small organization of memory had taken place, but the same organization can be taken place for a huge amount of memory here. So see, this is a very huge amount of memory where we are going to transfer here. We had transferred only of 8 bytes till now, D0 to G8, is it not? D0 to D8. See here, D0 to D8 means only uh, 8 bits of data were transferred. But the same organization can be done for a larger amount of memories. How this can be done is by doing this organization. Here, what is happening is 21 bits of addresses are again taken here. So 21 bits of address, among that 19 bits are used for telling the row address, and the remaining bits are used for telling which column we are going to select. Each column here is providing 8 bits of data. You can see D7 to D0 to D7, 8 to 15, 16 to 23, 24 to 31. 8 bits of data or 8 bytes of data can be provided by a single column. Uh, Everything else is the same. working procedure for static and dynamic all are same. Okay, same thing is happening, but only we are having a scale up here. Scale up means what? It is for larger larger memories here. So it is for larger memories. I told you 19-bit address is given, and the remaining 2 bits 19, 20, 21, 2 bits are used for selecting which columns. Here there are 4 columns, so 1 2 3 4. So for selecting 4 columns we require 2 bits, 0 0 0 1 1 0 1 1, like this. 4 0 0 means first one, 0 1 means second one, 1 0 means third one, 1 1 means fourth column. Like this, to specify which column we using, we are having a 2 bit remaining here. Each of them is having 8 bit data. 8 bit data will be given using the chip select. The same procedure is followed. So this is how you are going to do the transfer for larger memories. We will stop for today here. Next we'll be continue in the next class. Hope all of you have understood.